Hi, this is Real World Audio, and we are concluding our series of preamplifier block diagrams. What's happening inside your preamplifier? Maybe not yours, but inside generally in preamplifiers. So now I'm going to talk specifically about gain stages of vacuum tube preamplifiers, and what you see here is the basic building blocks that affect the sound quality in a preamplifier, and when you change any of these or each of these, there's going to be a change brought in to the sound quality and to the potential of that preamplifier. And basically when you use higher quality parts, the higher quality parts are usually bigger and heavier, so that's why you end up with scenarios like in the CJ GET preamp or other high-level preamps. You see those monstrously big capacitors inside, huge transformers, big resistors, not the size of a grain, but noticeably bigger size resistors. You see dedicated wires, and that's because each of these parts contributes to the signal quality. And if you have you can have two avenues how to voice your preamplifier. One avenue is voicing it for the lowest common denominator, that is making it universally compatible to all stuff, and that makes sure that it will sound acceptable with most gear, and it will sound good with most gear, but it will never sound excellent. And the other avenue you can choose is to specialize your unit with highest quality parts and no negative feedback, just as few parts as possible. Then you can get the absolute maximum out of a unit. And for example, in the, wow, I think that will be another video that I make, that what are the strategies that Conrad Johnson employs to achieve the sound that they have from their preamps. So right now, let's just stick around to the gain stage of a vacuum tube amplifier to see what's going on and what is affecting sound quality. So basically this diagram shows the vacuum tube, but the first part that affects the sound quality is the tube socket, because every part in your preamp or any amp or anything that has vacuum tubes, the number one thing it connects to is the tube socket. So the socket, the quality of it will be the first bottleneck and the first thing you have to calculate with it. And that's why when you have some like the more esoteric companies or higher level companies, they all use either very high grade tube sockets, or even better, they make their own. Or you know what, guys, what I did to my preamp that was my best sounding active preamp I ever had and ever made, I ditched the tube socket basically, or at least I made my own. So I used the Dacron material, which is very similar to Teflon, as the base onto which a tube connects, and I did not use metal pins for the connection, but I hardwired the preamplifier to the pins of the vacuum tube directly, so there is no more ability to tube roll, because the tubes are directly hardwired into the preamp, and basically that's the number one limitation of the tube socket, is that there's a metal in it that's holding the tube leg, and that metal rattles. That metal is not just a single piece of metal, it's multiple layers of metals. It has to be a lower grade metal, because you needs to have some sort of mechanical stability as well to be able to hold the tube pin. So you can not, or if you use like materials like silver to hold the tube pin, might not last too long if you do a lot of tube rolling. So anyway, the tube socket, when you get rid of that metal interface, there's a massive jump in the potential of the gain stage that you can have. So anyway, for the tube, as far as the signal goes, first we have the input. So that's where the input is going to the tube, going through a grid stop resistor. If there's one, then it's between the incoming signal and the grid of the vacuum tube. And that, oh wait, I think I made some errors here. So this thing should just be going to the tube socket. It just slid down. So this thing should connect there and not to the cathode bias resistor or whatever the cathode biasing mechanism. So the grid stop, imagine that this is going up here to the tube socket, and that modulates the flow of the high voltage that follows through this path. So basically there is a signal ground in the unit, and there's a wire hooking it up to the cathode biasing mechanism that makes sure that your tube is drawing a specific amount of plate current. So that sets the plate current. Now, this cathode biasing mechanism can be as simple as a resistor or can be very complex, like a regulator circuit there. And Conrad Johnson, for example, they love to use diodes in there, or there's often in many of the preamps, instead of just a high quality resistor and a capacitor or just the resistor itself, everyone loves to employ transistors there to regulate the current, to create a constant current source, which has the advantage of being constant current, but has the massive disadvantage of injecting the low level signal loss that occurs through such devices. And at a mid to lower level of gear, you usually see a massive advantage for using a constant current device to provide constant current. You will have a tremendous bass and power with it, but you put this preamplifier with that constant current stuff into a very high level, very revealing system, and you will notice that it does not have the lowest detail level. It's missing. There's a lot of power, but it's a mechanical power. It pushes it towards a mechanical taste. It's not natural sounding anymore. It's more of a showroom sound. And the same thing is happening with the load. The load is at the plate of the vacuum tube, and it basically defines how the output of the vacuum tube can be, provided it's a gain follower stage. And I mean, it's a gain stage and not a mu follow, not a cathode follower stage, because if it's a cathode follower, then the output will come from here, and in that case there will be no gain from this stage, which means that the voltage of the signal is not going to be amplified. It's going to be almost the same as the input voltage, a little less, but the impedance will be much lower than that of the signal that came through here. So basically, in that case, when using it as a cathode follower, then the vacuum tube will give us impedance matching, and that translates to much higher current of the signal. So then it becomes a current amplifier, which is similar to what transistors do, but without but in a way that a vacuum tube does this transformation, and not the way as a solid state device does this thing. However, when we get the signal from here, from under the load, then we have a gain in the voltage, but we do not have an advantage for the impedance. So it will still be a much higher impedance compared to what we get from the cathode. So the load is connected through a wire or a trace to this thing. Eventually here what you see is that it's getting high voltage from the power supply. So the high voltage supply is, oops, what's happening here? So the previous video, that's what I showed, what the power supply is doing, and after this there's one more arrow, and that goes to the trace here. And if it's a higher quality, well, not just higher quality, because these things are generally in most units, even at very cheap preamps, you have decoupling stages for each vacuum tubes, which one thing is that they lower the noise floor, the hum level that's coming from the power supply, but also they allow each stage to operate with a better reservoir of available power to drive it. And if it's a very high level preamplifier, then basically there's no need for these things, because each tube has its own high voltage power supply, which makes it vastly more expensive, because basically you have to multiply the power supplies in your preamp, and the power supplies tend to be the most expensive components inside a preamp anyway, and the biggest and the heaviest. So, but if you have a common power supply for all the tube stages, then you need to decouple them with a resistor or a choke, and then a capacitor. Also, you can, many lower level gear here use transistor regulator circuit to regulate the voltage. And the massive advantage of a regulator is its tremendously small size and tremendous cheapness, and it's being used instead of a resistor, because a resistor itself is, well, it's even cheaper and smaller than a regulator circuit, but it does not create such smooth supply voltage, and also there's a sag across it, so there's like, it has a lot of disadvantages. So basically using integrated circuit there or a transistor there to get the voltage regulated is some way a step up, that you are getting a lot of advantages in many areas, but it's inferior to using a choke, which is the absolute huge space waster. It adds a lot of space, weight and cost to the unit, and that's what is a big no-no for commercial products, because they want you to be able to buy the preamps to afford it. And when you have preamplifiers that have chokes in them, well, they almost exclusively are in the domain of DIY preamplifiers or extremely high priced preamps on the market. So basically you don't see chokes in any affordable units, because the cost does not allow it. So what I'm not showing here is that after the, so these are, let's just say what I am showing here is that all of these elements are going to impact the sound quality of your gain stage. One thing that I haven't mentioned yet is the filament supplies. Filament, that's the heater of the tube. So basically that's what makes your tube glow. And they are not in white background, they are in that shady background and blue color, because they represent not a single element but a group of blocks, and it's like massive slides. So all of these guys are basically this inside that little square, And now the load and the cathode bias, I also made it in blue color because they can be as simple as a single resistor, but they can be also a very complicated array of blocks within blocks. So I hope this helps everyone to understand a little bit how the parts in a gain stage affect the sound quality, and by changing each of these you affect the sound. And when you have a high level preamplifier, then basically all of these are high quality, and that's what makes something really expensive, because nowadays we have some ultra high quality parts available at absolutely ridiculous, ludicrous prices, and when you put it in a preamplifier, and you also give it a nice design, you also add the necessity to bring that product to the market, to pay the employees, to pay the design engineers, and to pay the dealers, to pay for shipping, boxing, whatnot, then it adds up to an absolutely ridiculous price tag in the end. However, do not despair, because you can also follow this path at home. So you can just build or modify a preamp for yourself using high quality parts here, and you do not have any of those massive added costs that need to go there. So basically talking about like a $20,000-$30,000 commercial preamp. If you want to DIY it, it will be just a few $1,000s. So like a 10 times price drop. But if you want to do that, if you just go about it randomly, it will be probably a failure. But I gave all of these to you so that you can look at what are the building blocks where you have to look out for the quality. And if you want to build something that's really gives you the highest potential of a preamplifier, then you need to take into account all of these things that I have shown. And of course, for preamplifiers, maybe as a last word, there are additional things such as remote control and Wi-Fi or whatnot, or built-in DAC. They will just absolutely degrade the sound quality if it's in a commercial amplifier, I mean preamplifier. If you take product A and product B, and they are costing the same price, and product B has all of these features built in, the only way they can market it and sell it to you at the same price is when they tremendously compromise the signal path, they compromise the power supply, they compromise the gain stage. Because if they don't compromise it and they want to put in a high level of, let's say, remote control, that's going to increase the prices out further. Because for the remote control circuit to not affect the operation of the main unit, the main signal portion of the preamp, it really needs its own power supply, it needs specific shielding, and now we are looking at very, very orbital costs. So thank you guys for tuning in. Please like, subscribe, have an awesome day. Bye bye.